Hello everybody. Here I have a Pasco wireless smart cart, a ramp which is raised at one end via a clamp attached to a retort stand. There's a stopper on the bottom of this ramp, and you'll notice I've got an iPad here, and what I can do is I can plot distance time graphs, velocity time graphs for this trolley for different types of motion in and around on the slope. I'd like to show you this cart first. So I'm going to come a little bit closer. Now hopefully you can see this. There is a set of axes labelled on here, and this trolley considers this direction to be the positive direction. So any velocity or displacement, distance moved in that direction is considered positive. The other way is considered negative. That's going to be important when we plot the graphs using this. So, prerequisite knowledge, scalars and vectors, hopefully you're okay with that. Displacement is distance in a given direction. So, for instance, let me show you. I'm going to connect the trolley to the iPad. So you can see me doing this live. I'm going to select the smart cart, put it on the table, and we're going to plot position against time. So I'm going to leave it stationary. I'm going to start collection. So you'll see that the position time graph is just showing that it's at position 0 at the moment. If I move it in this direction, what is the positive direction for the trolley? I move into positive displacement. Okay, so I'm now half a meter, positive half a meter from my original position, which was about there. If I move it the other way, in the opposite direction, the negative direction, the displacement's considered negative. So you can see it's quite a neat software. I can plot a displacement time graph for the trolley. What I'm going to do now, and I'd like you to think about what this is going to look like, is put the trolley at the top of the ramp and then release it and plot a displacement or position time graph for that motion. So I'd like you to pause the video and think about what that's going to look like. You might even like to sketch it. Have you done that? Okay, let's go. Start. So you can see the position time graph. Think about how the speed of the trolley is changing and what effect that has on the graph. What feature of the position time graph, displacement time graph will reflect the fact that the trolley is speeding up as we go down the slope. Watch what happens if I turn the trolley around so that it's moving in its negative direction. So I'm going to, hello Mr. Hearn, I'm going to release the trolley and we're going to plot the position time graph for this. So let me restart that. And you can see that the displacement is now considered to be negative because it's moving in the negative direction. Next, velocity time graphs. So let me change the axis here to velocity. My screen share. Oh, there we go. That's better. So I'm going to click start. Think about what the velocity time graph is going to look like. Right. So you can see the velocity starts at 0 because it starts at rest at the top of the slope, but it increases as the trolley moves down the slope. And you can see that because this is a straight line, that tells us something about the acceleration. It tells us something about how the trolley is changing its velocity. So have a think about that. And also think about what it's going to look like, the graph, if I turn the trolley round so that it's now moving from its point of view, of course, backwards. So it will consider these velocities negatively. It should be no surprise that we get something that looks like this. Because the motion's the same, it's accelerating in the same manner, it's the same trolley, it's the same ramp, but now we're moving in the direction this trolley considers negative, so the velocity is negative, the straight line is on the lower half of the velocity time graph. Okay, I hope that's been useful. Thank you very much.